Now we want to put these two parametric equations into a y equals f of x form. That graph that we just saw is a function of y is a function of x, and we can obtain that function of x from these equations. Now what we get when we do this sort of thing doesn't always give us y as a function of x. It could be a relation where we have two y values for a given x. There's nothing that prevents that in a set of parametric equations. In this case, it turns out that that's not the case. We do get a perfectly good function y equals f of x. Okay, if we first solve the equations, okay, well, our strategy, to get y as a function of x, we're going to solve this equation for t and plug that t in here. T will be a function of x here, so that we plug it in for t, we're going to get y as a function of x. So, if we solve for t, x equals 2t cubed plus 1. I'm not going to go through the details of that solution, but we pretty quickly get t equals the cube root of x minus 1 over 2. And that's a very straightforward solution. You should be able to do that. If you have trouble, holler at me. Got y equals t squared minus 1. If we plug in the cube root of x minus 1 over 2, we get this, which is, of course, x minus 1 over 2 raised to the 2/3, and then minus 1. So there's our function. Okay, so the procedure is pretty straightforward. The arithmetic, for example, if you've forgotten how to do radicals, exponents, fractional exponents, and so forth, you might have a little bit of trouble with this. But it's really fairly straightforward. In outline, you simply solve one equation for t and plug it in to the other. Now, if we were to graph this equation here, or this function, go to derive, author the function, and graph it, you get the same thing you would get if you graphed the two parametric equations.